Jai Hind to all. Myself, Shikha Agarwal, Assistant Professor in IT Department of Ajay Kumar Garg Engineering College. So, today we are going to discuss about one complex topic of artificial intelligence, that is a reasoning in artificial intelligence. I would like to dedicate this lecture to my mechanical engineering students so that they will learn the basics about artificial intelligence, and out of that they will learn what do you mean by the term reasoning, so that they can learn methods. So if I'm talking about the term reasoning, whenever I'm using the word reasoning, basically we can say this term is being derived from our conclusions. What do you mean by the term reasoning? Basically, if we are having a given methodology, and on the basis of that methodologies, if we want to derive a certain conclusions so that we can give a desired output, then we can talk about the term reasoning. Basically, when I'm talking about a reasoning, it is a process of thinking, right? If the human being is doing a process of thinking, if I'm talking about thinking, in that case, they are thinking either logically, right? Or they are thinking about doing an arguing into the system. And on the basis of that, when they are drawing the logical conclusions, then we are talking about the reasoning, right? When a system is required to do something, into that case, generally they used to do an explicitly or implicitly how they have to do it, how they have to figure out the things, and in the manner in which they have already know about the base of the system. Then we are talking about the concept of reasoning. Basically, reasoning is a mental process of deriving a logical conclusions on making the predictions from the available knowledge, facts and figures or the beliefs, right? Suppose we are already having a certain data. On the basis of that certain data, if we draw the conclusion, and on the basis of that conclusion, if we are trying to come a logical conclusion, if we are trying to make a predictions, and on the basis of that predictions, if we are deriving a logical conclusions, then we can say we are talking about the term reasoning. In the term of AI, if I talking about a reasoning, it is a way to infer the facts from the existing data. Whatever the things is being available, that is, in the basis of that, we have to draw the figures. Then after that, we can say, when I'm talking about the reasoning, it is a general purpose of thinking rationally, right? We will discuss one after another how we have to do the work. So after thinking rationally or logically, we have to find or we have to validate the conclusions. So in the artificial intelligence, it is very necessary or it is very essential so that the machine can also think rationally like a human brain, and it will perform the conclusions, it will draw the conclusions in the similar manner like a human being can think about it. Suppose if I talk about an example, let's discuss about one example. If I say for fact 1, if we are talking about the given facts, if I say the fact 1 says Robin, if I am talking about the fact that Robin are birds, right? This is the first fact which we already know, right? So then, if on the basis of that, if we given the second fact that all birds having wings, if we given a fact, the second fact that all the birds are having a wings, so on the basis of that, we can draw the certain conclusions on the basis of the given reasons. What is the reason? That we can think like if we are thinking like a human being, that is Robin having wings, right? If we draw the conclusion on the basis of that, so we will ask a question itself that comes to my mind, that is a Robin, right? Because we have already told that Robin are birds, right? So we can ask themselves that is Robin have wings? right? So into that case, on the given facts, the two facts is being given, and on the basis of that, we have to draw the given conclusion. And that particular conclusion is logically correct because we are thinking rationally. Into that case, how we can think about it? It is already given in the first fact that robin are birds. It means the name of the bird is robin, right? Then after that, in the second fact they have given, all the birds are having wings. It means whosoever is the bird is having a wings. So on the basis of that, we have asked themselves, which we are thinking rationally, and we came to a conclusion that it is a bird and having a wings or not, right? So on the basis of that, we comes to derive a conclusion, right? So we can say we are talking about a reasoning. So it means when I'm talking about the term reasoning, it means deriving a conclusion. Deriving a conclusion. It means we are talking about reasoning, right? Then after that, let's discuss about the different types of reasoning. In the case of artificial reasoning, in the case of artificial intelligence, we have divided the reasoning into the various categories. The first is called deductive reasoning. The second is called inductive reasoning, right? The next is abundative. The next is common sense reasoning. The next is monotonic. And the last is non-monotonic reasoning, right? So these types of the various reasoning. So first of all, we are going to discuss about the deductive reasoning. When I'm using the word deductive, it means we have to deduce a new information in which we have to apply the knowledge and we have to use the existing information. So we can say when I'm talking about the derived reasoning, it is a way of deducing a new information from the logically related known information, the information which we already know about it, and after getting that information, we come to a conclusion that what is the new information can be generated. Then we can say it is a type of a deduced, or you can say deductive reasoning. Basically, it is the form of a valid reasoning in which we make an arguments, conclusions that must be true when the premises are true, right? When we know the given facts are already true, then we can say we can draw the conclusion, and whatever the conclusion or argument we generate, that is also true. In the previous lectures, we have already gone through a propositional logics. So deductive reasoning is a type of a propositional logic in AI. And similarly, it certainly requires the certain rules and facts in which it is also referred to be as a top-down reasoning method, right? And on the contradictory, we have to talk about the inductive reasoning, fine? In the case of deductive reasoning, the truth of the premises gives the guarantee that whatever the conclusion we draw, it is also true. In the case of deductive reasoning, mostly starts from the general premises in which we are giving the general conditions and we are moving towards the specific conclusions, right? Then we are talking about the deductive reasoning. Let's see one example. Suppose if I'm talking about this example, the first premises or the fact says all the human eat veggies, right? If I say that whosoever exists in the world is a human being and that human being eats veggies, all the human being eat veggies. And on the basis of that, if we given the second premise that Suresh is a human, this is the name of a person, that is a Suresh, and we say it is a human, right? So if we say that all the humans eat veggies, all the human, it means Suresh is also a human being. So on the basis of these two facts or the premise, we came to a conclusion that Suresh eat veggies, right? So this is a deductive reasoning. On the given facts, right, or on the given information, we have drawn a new information. We have derived a new information, right? This is called deductive reasoning. The next, if I'm talking about the deductive reasoning, what is the general process of doing a deductive reasoning? into that case, first of all, we will check the theory. Whatever the theory is being given to us, and on the basis of the given theory, we have to think hypothetically. On the basis of given theory, we have to generate the hypothesis work. Whatever the situation is, how we have to enact, and what all the possible circumstances can be possible. Then on the basis of hypothesis, we have to generate the patterns. We have to generate the various combinations, that what all the cases or what all the truths can be possible. And simultaneously after that, we have to generate the confirmation of the given truth from the given theory, right? This is called deductive learning, reasoning. Then after that, we are going to talk about an inductive reasoning. If I'm using the word inductive reasoning, basically it is a form of a reasoning in which we have to arrive at conclusions by using a limited set of facts by the process of generalization, right? Here we have to apply the concept of generalization, and on the basis of those generalized form, it means we are having a limited facts, and on the basis of that giving limited facts, we came to arrive to a conclusion in which we have to start with the series of specific facts or the data, and finally we reach to the general statement or the conclusion in which we have to think rationally. If I'm talking about inductive reasoning, basically it is also known as a cause-effect reasoning, and it is also based on the bottom-up approach, right? In the case of inductive reasoning, we use a historical data or the various premises in which we have to generate a generic rules and regulations. And those rules and regulations or the facts are those which supports the conclusions. So in the case of inductive reasoning, premises should probable support to the conclusion so that we can generate the truth, and we can say that the truth does not give a guarantee that whatever the conclusion we have drawn is to be true, right? So whatever the conclusion we are using, it is not necessary that truth is to be true also, right? So you can check one example. The example says, first we are giving a one premise. That premise says all the pigeons we have seen in the zoo are white, right? So it is given in the premise or in the fact that there are many pigeons in the zoo, and whatever the pigeons I have seen, they all are a white in color, right? Then on the basis of the given premise or a fact, we draw a conclusion that we can expect that all the pigeons are to be white they are to be of white color only. But we cannot give the guarantee that all the pigeons are in the zoo are of white color, because we have not seen all the pigeons. We have not noticed all the pigeons. So we cannot say that all the pigeons are of white color, whosoever is in zoo. But we can say that I expect that whatever the pigeons are there in the zoo, they all are of white color, right? They can be a brown color, they can be on any other color also, but we came to a conclusion that they are of white color, right? So in this case, we have to generate a inductive general process. First of all, we have to find the observations. What is that observation? We were continuously observing the pigeons. We are moving from one location to another location in the zoo, and whenever we are finding the pigeons, so we are observing whether they are of white color or not, right? So we have to find the various observations. Then after that, we have to generate the patterns, right? Patterns is this location, white color. This location is of white color. This location is of white color, and so on. So we are generating the different patterns. Then after that, we have to find the hypothesis of the given parameters. Whatever the patterns we have generated, we have to apply the hypothesis. And finally, we get the desired theory, which theory says that I expect whatever the pigeons I have seen in the zoo, they are all of white color, right? So maybe we expect to, or we come to a conclusion. That conclusion can be true or false. that we came to a conclusion that we expect that the pigeons which are there in the zoo are of white color. Right? Then after that, we are going to talk about the next type of a reasoning, that is called as an abductive reasoning. Basically, the abductive reasoning is an extension of deductive reasoning, right? Because in the previous the 10 minutes before, we have gone through the deductive reasoning. And in the case of deductive reasoning, we are deduced to a new information from the existing facts. Okay? So, into this case, in the case of abductive reasoning, basically this is a form of a logical reasoning which starts with a single or multiple observations. Either we see a single observation or we see a multiple observations. That seems to be like or most likely explanation or conclusion from the observations. Basically, in the case of abductive reasoning, the premises does not give a guarantee for the conclusion. Right? So, you can see an example also. When I am talking about the example in the case of deductive reasoning, in the case, if I say if it is an application is given, cricket ground is wet if it is raining. Right? If it is raining, then we can say cricket ground is wet. And on the basis of this implication, we generate or we know the axiom and think that cricket ground is wet. Right? So, if it is given already that cricket ground is wet, so on the basis of that, we have come to a conclusion that maybe it was raining or it is raining. Right? But it is not necessary that if the ground is wet, it is because of raining only. Right? So, but because this does not give a guarantee for the conclusion. Right? Lekin still, because we have already given an implication that if it is raining, the cricket ground is wet. So, we hypothetically think about it that yes, the ground is wet, maybe it was raining. Fine. So, this is called as an abductive reasoning. After that, we are talking about a common sense reasoning. When I am using the word common sense says in our day-to-day life, we are making a lot of assumptions. Right? On the basis about that events, that this may occur, this may cannot occur, and so on. Right? So, this is called as a common sense reasoning. In the case of common sense reasoning, it is an informal form of reasoning in which we have gained a lot and we are coming to a conclusions on the basis of our experiences. So, we can say the common sense reasoning stimulates the human ability to make the pre-assumptions about the particular event which is to be occur in our day-to-day life. Right? And basically, we are making a good judgments rather than exact logic or operates on heuristic knowledge. We are not applying any knowledge or any heuristic rules onto the given data. We are only based on the judgmental way, because we generally used to assume that we are the good judgmentals. Right? So, we can, whatever that we can judge, it's to be the correct statements. Let's see one more example. In the first example, it says one person can be at one place at a time. Right? We assume that one person can be available at one place at a time. This is our daily assumptions. Right? Second thing, we make an assumption, if we put a hand into a fire, then it will burn. It may or may not it will burn, but we have already making an assumptions on our own human abilities, which based on the events which occurs in our day-to-day life. Right? So, in both the statements, you can think that these are the examples of common sense reasoning in which the human mind can easily understand and assume itself. For example, if I say, generally we used to say to the kid, don't run fast, otherwise you will fall down. Right? He or she may or may not be fall down, but we used to make an assumptions that if you run fast, maybe you will fall down. Similarly, here we have make an assumption, if I put my hand into the fire, then it will burn. This is called as a common sense reasoning. Then after that, we are going to talk about a monotonic reasoning. In the monotonic reasoning, we are talking about into that reasoning in which once the conclusion is being taken up, then it will remain the same. Even if we add more or more some other information to the existing knowledge base. If we already having a knowledge and on the basis of those facts or information, we have already drawn the conclusion. And after certain amount of time, we are getting a more knowledge, right? So still we are not changes our conclusions. We are fixed to the output, that whether we are adding a more or some other information into that existing information or not. So in the case of monotonic reasoning, if we are adding a knowledge, it does not it will not decrease the set of prepositions that you can derive. Whatever the prepositions you have derived, it will not make any changes, or it will not decrease also. So to solve the monotonic problems, we have to derive the valid conclusions from the available facts only. And whatever the facts we have, it will not affect by the new facts. Whatever on the basis of available facts, we have drawn a valid conclusions. And if we add a new fact or the new information into the existing information, it will not affect onto the data, right? So in the case of monotonic, generally it is not useful for the real-time systems or on the real-time applications, because here facts get changed, so we cannot use monotonic reasoning. Monotonic reasoning is used in a conventional reasoning methods, which is generally based on a logical based system. In those examples, we can use the monotonic reasoning. Any theorem provide as an example of monotonic reasoning, right? You can see an example. Earth revolves around the sun. This is a true fact that the earth revolves around the sun. Are you able to change into this statement? Right? So we cannot be changed even if we add any other sentence into the knowledge base. Right? If I add like the moon revolves around the earth is round, and so on. Whatever the statement you add, or you add some any other additional information into the statement, but this statement or this conclusion can never be changed, that the earth revolves around the sun, right? Because this is a true fact and you cannot make changes to your conclusion. Now, if I'm talking about monotonic, there are the various advantages and disadvantages. In the case of monotonic, each old proof will always remain valid, right? So generally we are using in a hypothetical theories, we apply this monotonic into a old conceptual theories in which we are generating the proofs, and those proofs will remain valid. It will not get changed whether we are getting more and more new information or not. If we deduce some facts from the available facts, then it will be remain valid for always. Suppose initially we were having a small facts, and on the basis of that we have already decided the valid reason, the valid conclusion. So we are always to be fixed onto that conclusion, that this reason will not be changed. But if I'm talking about its disadvantages, there are various disadvantages can also be possible. The first disadvantage, that we cannot represent the real world scenarios by using the monotonic reasoning. The second, the hypothetic knowledge cannot be expressed with the monotonic reasoning because the facts should be true. So whatever the hypothetic facts or knowledge we have, we cannot express by using the monotonic. Since we can only derive the conclusions from the old proofs only, so if we add a new information from the real world, that is of no use, or we cannot add it, because we have already derived one conclusion, and that particular conclusion from the old proofs is already a true fact, true reason, true solution. Then why we need to add more and more data, new knowledge of the real world? Then you can say this is the disadvantage of using the monotonic reasoning. The next is non-monotonic. The non-monotonic reasoning in which some conclusions may be invalidated if we add some information or more information to the knowledge base, right? The logic which set as non-monotonic, in which some of the conclusions can be invalidated by adding more information into the knowledge base, right? So generally in the case of non-monotonic, it deals with incomplete and uncertain models. Generally, we are talking about the human perceptions in the various day-to-day life, because the human perception changes time to time. So we are talking about a non-monotonic reasoning. In this case, we have to talk about one example. If I am using about the knowledge base that consists about the various knowledges, birds can fly. First example we are giving that the birds can fly, right? Second fact we have given, penguins cannot fly. So we can draw a one hypothetical conclusion that penguin is not a bird, right? Although it is a bird, right? The next after that we are taking as Bitty is a bird. It's a name of a bird, Bitty, right? So from the above sentences we can conclude that Bitty can fly, because Bitty is a bird and we have already drawn that birds can fly. So we can say Bitty can fly, right? But if we add one more sentence into the knowledge base, that Bitty is a penguin. If I add one more sentence to the above statements here, then into that statement if I write Bitty is a penguin, and we have already written that penguins cannot fly. So, and here we have drawn a one conclusion that Bitty can fly. Now conclusion changes, and into that case we can say Bitty cannot fly. So it is invalidates the above conclusion. We have conclude that Bitty can fly, and after adding a more information into the existing data, then we can say Bitty is a penguin, and on the basis of that conclusion we have drawn that Bitty cannot fly. Fine. So that is why it is called invalidated. Okay. Now the advantages of using a non-monotonic reasoning, that it is being used for the real world systems like robots, navigation and so on. And simultaneously in the case of non-monotonic reasoning, we can choose the probabilistic facts and we can make the assumptions, right? And the disadvantages is that in the non-monotonic reasoning, the old fact may be invalidated by adding the new sentences, and it cannot be used by the theorems which is being already proven. Now you can see the in this lecture we have explained about various types of reasonings. So we have covered the 6 types of reasoning. After that, we came to know that these two are very important types of reasoning. So into this case, let's discuss about the difference between the inductive and the deductive reasoning in the below diagram. Suppose we are having a one argument, and into this argument, if I am talking about a deductive reasoning, it generates the 2 types of condition, valid or invalid. Invalid is unsound, and valid is sound or unsound both, because all the valid, all the premises, it should be true. But similarly in the case of inductive, we are giving the 2 types of outputs, that is a strong or weak. If it is strong, we are having a cogent and uncogent, and in the case of weak, it is an uncogent output, right? On the basis of the arguments, let's discuss about the various differences between the deductive and inductive reasoning. The first difference I have already told you in their approaches, right? So if I'm talking about the approach, deductive is a top-down approach and inductive is a bottom-up approach, right? If we are talking about the definition, deductive reasoning is the form of valid reasoning so that we can deduce a new information or the conclusions from the known related facts and informations, right? But in the case of inductive, we are arriving a conclusion by the process of generalization. We have to start from the premises in the case of deductive because it is a top-down approach. But in the case of inductive, we have to start from the conclusions. What is the validity? In the case of deductive, conclusions must be true. Why? Because all the premises are true. Okay? And in the case of inductive, the truth of the premises does not give the guarantee for the truth of the conclusions. Right? Maybe their premises is to be true, but it does not give guarantee that whatever the conclusion you draw is to be true. We have already discussed its process in both the cases. Now, if I'm talking about the usage, in the case of deductive reasoning, it is difficult as we need a facts because everything is must to be true. But in the case of inductive reasoning is fast and it is very easy because we have to generate, instead of true facts, we have to talk about the day-to-day life, right? In the case of arguments, in the case of deductive reasoning, there are the arguments is to be valid or invalid. But in the case of inductive, it can be weak or strong. In the case of a structure, if I'm talking, deductive reasoning reaches from the general facts to the specific facts. But in the case of inductive, it reaches from specific to the general notations, right? Now, in this, we have discussed all these types of reasoning. There is one more type of a reasoning is being used in artificial intelligence that is called probabilistic, right? As we have already covered the first order predicate logics, right? And on the basis of that knowledge representation, we generally used to write A tends to B, which means that if A is true, then automatically B is true and vice versa. But consider a situation where we are not sure about whether the A is true or not. There are certain situations come, then we can say that A is true or not. So we are not sure about the condition. So into that case, we cannot come to a conclusion that A tends to B or not. Right? So on this situation, it is called uncertainty. And whenever we represent an uncertain knowledge in which we are not sure about the predicates, into that case, we require a one type of reasoning which is called uncertain reasoning or probabilistic reasoning, which does not give the guarantee or which does not express this statement that whether what is the conclusion is being drawn or what are not sure about the predicates. Then we need to talk about the probabilistic reasoning. There are the various causes due to which the uncertainty occurs in the real world. We are not aware about it and we are not doing intentionally. But sometimes it occurs itself in the real world. For example, information occurred from an unreliable resources. We are talking about the unreliable sources. It means we are getting the information from the second person. We are not sure about that information, whether it is correct or not, right? There is an experimental errors. There is an equipment faults. While using any equipment, you cannot say that you are not sure about the result. There is a temperature variation. There is a climate changes. So these all are the various causes of uncertainty in which you cannot make sure that whether the data is correct or not. These conditions are called uncertain reasoning or probabilistic reasoning, right? So we can say the proper definition of probabilistic reasoning is, it is a way of knowledge representation where we apply the concept of probability to indicate the uncertainty in knowledge, in which we combine the probability theory with logics to handle the uncertainty into the data. It is called probabilistic reasoning. We can use the probability to solve the probabilistic reasoning. Why? Because we are to handle the way of uncertainty. That is the result of someone's laziness or ignorance to that particular confirmation of data. Right? So into that real life or real world situations, there are a lot of scenarios comes into the real world in which uncertainty is there. We cannot give the certainty of something which is not to be confirmed. I can give you one example. If I say it will rain today. If I say it will rain today. So according to you, if I say it is raining today, so it is surety. But if it will not rain, then you will say your statement is false. So behavior of someone for particular situations, right? So we cannot give the guarantee for that particular conclusion. Then we can say we have to use the probabilistic reasoning. One more example I can say, a match between the two teams or two players. Sometimes we used to watch the cricket and one is bowling and one is batting. Into that case, they both are continuously playing very well. So we used to say whether the match is between these two teams or they are fighting themselves itself only. Right? So these are the probable statements in which we can assume that it will happen, but we are not sure about it, in which conditions will be happening. Conditions will come, but we are not sure about the result. Then we can say we have to use the probabilistic reasoning. Under the probabilistic reasoning, we are going to discuss about the Bayesian network, Bayes theorem. Right? So this is all about the reasoning. Now, in the case of need, why we need? Because sometimes we need to come for an unpredictable outcomes. Sometimes when specifications and possibilities of predicates becomes too large to handle it, or sometimes an unknown error occurs in an experiment, during an experiment, then we are required the probabilistic reasoning, right? So this is all about the basics of reasoning. These are the two textbooks and references books which you can prefer for your further knowledge. Thank you.